Alright, so today we're talking about OR probability. Two events are said to be mutually exclusive if they have nothing in common. Mutually. So, both events can't happen at the same time. If I take a look at number 1, it's asking me to find the probability of drawing a 4 and then just separately find the probability of drawing a face card. There are 4 4s. So there is a 4 out of 52 chance, which simplifies to 1 over 13. For the face card, there are 12 of those. So I have 12 over 52, which simplifies to that one I don't know off the top of my head. Three over 13. Okay. Part B wants me to draw a Venn diagram that shows the probability of these two events happening. So, okay, this first one is going to be the probability of grabbing my 4s. There are the 4 of hearts, the 4 of diamonds, then there's the 4 of clubs, and the 4 of spades. Okay. For my face cards, there is the Jack of Hearts, the Queen of Hearts, the King of Hearts, the Jack of Diamonds, the Queen of Diamonds, the King of Diamonds. Then there's the Jack of Clubs, Queen of Clubs, King of Clubs. Then there's the 4 of 4. Should be a Jack. Jack of Spades, Queen of Spades, King of Spades. Okay. So looking at our Venn diagram, notice these two events don't occur at the same time. So what I want to do is I want to count the probability of drawing a face or a 4. If I count them all up, there are 16 different cards, over 52 total. Then I want to type that in my calculator and simplify. It simplifies to 4 over 13. Okay. So if I look at my parts A and C, what's the relationship? I don't know what I'm writing here. I wanted to say A adds to C. So notice 1 over 13 plus 3 over 13 adds to 4 13ths. Okay. When two events are mutually exclusive, you just add them together. Right there. Okay. Number 2 says a restaurant has 3 pieces of apple pie, 5 of cherry, and 4 of pumpkin in its dessert case. If a customer selects one kind of pie for dessert, find the probability it'll be cherry or pumpkin. So I want to count. There are 3, 5, and 4. So 3 plus 5 is 8, plus 4 is 12 pies. Okay. Then I want to count how many are cherry. There are 5 cherries. And pumpkin is 4. So what I do, since they're mutually exclusive, it doesn't matter. You can pick either cherry or pumpkin. You just add. I have 9 over 12, which simplifies to 3 over 4. Okay. C is telling me a card is drawn from the deck. I want to find the probability that it's either a club, a diamond, or a heart. There are 13 clubs, 13 diamonds, 13 hearts. None of these overlap. And there are a total of 52 cards. So I have 13 over 52 plus 13 over 52 plus 13 over 52, which gives me 39 over 52. Don't ask me why, this one simplifies to 3/4 as well. So So then when two things are not mutually exclusive, so they can both happen at the same time, I use this formula. So I add them together and I subtract the piece that overlaps. So I want to find the probability that I draw a card that's either a king or a red card. So there are 4 kings and 26 red cards. And then of those red cards, I have the King of Hearts and the King of Queens. King of Queens. It's a show. King of Diamonds. Okay. Then, so there are 2 overlapping cards. So my probability of my first event is 4 out of 52 kings. My second event is 26 out of 52 red cards, and the overlapping piece is the 2 kings, so I subtract the 2 out of 52. So then I add my numerators. 4 plus 26 is 30, minus 2 is 28. And then I type that into my calculator to simplify, which gives me 7/13. Okay. On number 5, it says 2 dice are rolled. It says find the probability of getting doubles or a sum of 6. Doubles means 2 of the same dice. There are 6 of those. And for things that sum to 6, there's 1 and 5, 2 and 3, 3 and 2, 1 and 5. These should be adding to 6, not 5. So there's 2 and 4, 3 and 3, 4 and 2, 5 and 1. So there's 5 that add up to 6. Of those, one of those is a double. It's 2 of the same, 3 and 3. So I have to subtract 1 over 36. So 6 plus 5 is 11, minus 1 is 10. 10 over 36 simplifies to 5/18. Number 6 says in a hospital there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are female. If a staff person is selected, find the probability that the subject is a nurse or a male. So what I'm going to do is I am going to make this into a chart. I have my staff, which is nurses and physicians. And then this is going to be total. Over here I have females and males and total. We'll pretend I can draw straight lines. So in the problem, it tells me there are 8 total nurses and 5 physicians. Then it tells me 7 nurses and 3 physicians are female. Okay, so what I first want to do is I want to fill out the rest of this chart. So I know for total columns I can add 7 plus 3 is 10, 8 plus 5 is 13. Then over here, I'm subtracting to find the middle missing male column. So 8 minus 7 is 1. Why is this pen not wanting to work? 5 minus 3 is 2. And I can either add 1 and 2 or subtract 13 and 10 to get 3. If it doesn't both come out to the same number, it means I've made a mistake somewhere inside. So it wants me to find the probability that if a staff person is selected, the subject is a nurse or a male. So there are 8 out of 13 nurses, and there are 3 out of 13 males, and there is 1 out of 13 male nurse. So I add the first 2 and I subtract the overlap. So 8 plus 13, 8 plus 3 is 11, minus 1 is 10. 10 out of 13 chance that they get either someone who is a nurse or a man.